10.6 Sun, Stars, and Galaxies. So God made two great lights, the greater light to rule the day and the lesser light to rule the night, and he made the stars also. All right, a few things about the sun. So it is a typical star in its size, its shape, and its temperature. It provides heat, light, and energy, and it has a gravitational pull that keeps the planets in orbit. The core, so hydrogen atoms are constantly fusing and releasing atomic energy in the process at the core. It is the center of the sun. It has another part called the photosphere. So there you're going to find granule, which means bubble. It is a convection cell and it lasts about 20 minutes. This is the visible part of the sun. You can also have supergranule. This is a larger convection cell, so they actually last a lot longer. They last about 12 to 24 hours. On the photosphere, you can also see sunspots. These are dark patches caused by the sun's magnetic field, and they are cooler than the granules. Another part is the chromosphere. So this is actually located outside of the photosphere. And chromo means color, so it's sphere of color. It is the lowest layer of the sun's atmosphere, and it has these spicules. So these are flame-like columns of gas that continually erupt. It also has filaments. These are dark lines that appear to thread the surface. The spicules are sometimes interrupted by these tremendous bursts of energy known as solar flares. They can also have solar prominences. These are streams of dense gas erupting off the chromosphere, and they return in this loop-like kind of fashion. Then you have what is this transition region outside of the chromosphere. It is a very thin layer and it releases ultraviolet radiation. The outermost layer of the sun's atmosphere is, of course, the corona. It's a huge hot blanket of gas that extends hundreds of thousands of kilometers from the transitional region. So the coronagraph is a device that blocks the light from the photosphere, and they have coronal holes. These are the main source of solar wind, which is high-speed streams of charged particles that are ejected from the sun. Most of the solar wind is going to end up being blocked by the Earth's magnetosphere. I don't know if you guys remember us talking about that. I think it was probably like 2 or 3 chapters ago. All right, so stellar measurements. So you have to be able to give a way to express the enormous distances between stars and planets and all this other thing, and you can't really use measurements that we do here on Earth. So a light year, this is the distance that light travels in 1 year. It's about 186,000 miles per second. Then you have the parallax. So this is the apparent change in the position of an object caused by an actual change in position of the observer. So then you could have a stellar parallax. This is half the angle that the star appears to move on the celestial sphere when viewed from opposite sides of the Earth's orbit. So basically, the larger the stellar parallax, the closer the star is to Earth. Then you have parasec, that is the distance to stars. All right, so we're going to talk about star magnitude next. So first off is the apparent magnitude. So this is the brightness of a star as it appears to an observer on the Earth. This was measured into a system developed by a Greek astronomer and mathematician. So the lower the apparent magnitude number, the brighter the object is going to be. The apparent magnitude of a star is going to depend not only on its actual brightness, but also on its distance from the Earth. So the absolute magnitude is the apparent magnitude that the star would have to an observer located 10 parsecs from the sun. All right, there's all sorts of different star categories. So a star's color is going to depend primarily on its surface temperature. So our sun, of course, it looks to be like this yellow color. So it's about 6,000 to 5,000 degrees Celsius. A star's absolute magnitude is going to depend on its surface temperature and its size. So then our book talks about HR diagrams. So these are the Hertzsprung-Russell diagram. So it's a two-dimensional graph that compares stars by their temperature and by the amounts of light they produce. You could have giants and you could have supergiants. So these are bright and cool stars. The main sequence is considered your average stars. Our sun is a yellow star and it's near the middle of the main sequence. It's not a giant or a supergiant. Then of course you have your white dwarfs. These are small and dim stars. Stars can also appear in groups, kind of like we mentioned before. Binary star, this is a system in which two stars are bound together by gravity. Sirius, it's the brightest star in the winter sky, and it's actually two stars. Half of all stars, of course, are visible binary stars. Optical double, so you have a pair of stars that are close on the celestial sphere but far apart in space. Triple star means three stars, of course, grouped together. Then you could also have multiple stars, so that's a group of more than three. Open clusters are loose asymmetrical clumps containing tens to hundreds of stars. Globular clusters, these are tightly clumped spherical groups of thousands or millions of stars that travel outside the boundaries of the Milky Way. Now, we could have stellar explosions. So a nova is where a star suddenly flares up too many times its original brightness. Then, of course, you would have a supernova. That is going to be the actual explosion of a star. Nebula is the cloud of interstellar gas and dust. And then you could have pulsar, a rapidly rotating neutron star that emits directional beams of radio waves. A galaxy is a massive star system containing millions to billions of stars, gas, and dust. So the Milky Way is the galaxy in which we live. But galaxies are also grouped together in different clusters. So the cluster we are a part of is known as local group. We are not the biggest galaxy in the local group. Andromeda is actually going to be the largest one. Some other galaxies are listed here. You could have superclusters. So these are clusters that are grouped into these larger structures. Getting on to some different shapes. You could have a spiral-shaped galaxy. You could have a barred spiral galaxy. So astronomers think that the Milky Way is a barred spiral galaxy with two major arms and several smaller arm segments. Black hole, that is an object so massive and dense that not even light can escape its gravity. All right, next is elliptical galaxies and irregular galaxies and lenticular galaxies. You could also have barred lenticular galaxies. Here we have pictured the nebulae and quasar. So quasar, it's an extremely bright object that emits both visible light and radio waves. And then the nebulae, so large clouds of gas and dust floating in space.